Okay, hello everyone. Welcome to our next talk, Lightweight, real-time and offline data storage on Android without a database. So, my name is Markus Kett. I'm CEO and co-founder of MicroStream. I work with in the Java environment for more than 20 years now. With my team, we were working on many open source projects, and currently we work on the Eclipse Store project for storing data. So with cloud and NoSQL databases, the amount of data was increasing more and more. And now with IoT, virtual reality, with AI and machine learning, the amount of data is exploding and will be explode, of course. And there are three critical factors for all of these modern, awesome applications. High performance, of course, low data storage costs, and simple implementation. The challenge here is, or one of the biggest problems, using traditional databases mostly leads to slower apps, to expensive latencies, high complexity in the system, and let cloud costs explode. So with my team, we worked on a Java IDE based on Eclipse. For many years, we worked on the JBoss Hibernate tools to improve database programming with Java for many years. And the problem was, one day we realized we cannot improve this anymore. It's because there are fundamental problems, technical problems we will never be able to solve. Why? So it's because when we use our programming languages like Kotlin, Java, or other programming languages, everything is great. So we can do almost everything. We can build an ERP system, we can build AI machine learning algorithm or mobile apps. No problem, we can do whatever we want. And we can use all data types, all data structures, so we can consume sensor data very easily. We can create graphs in the memory with circular references, so really complex data. This is not a problem for us because we are developers, because the programming language is awesome. But as soon as we want to store data persistently on disk, the challenge begins. So then we are in trouble because all databases on the market are, from a technical perspective, incompatible with the object model of our programming language. So we have some or many impedance mismatches here. So the object model is different to the relational model. Subtypes are not possible in the relational model, and so on. Data type differences. So we have to map our classes to a database model, no matter which database you are using. So it's the same with the modern NoSQL databases. So they also introduce new data structure, but they are also incompatible with the object model. It's the same with the object-oriented databases. So they had also the idea to store objects in a database, but the object model of the object databases are also their own proprietary object model. So we have to map our objects to these database models. Of course, it can be solved. We need a mapping in between. So object relational mapping, or if you use a NoSQL database, you need a data conversion, just like JSON, for instance, through every single read and write. And this is very expensive. So you can read more about this impedance mismatches in the internet. And it can be solved, of course, but it leads to really expensive latencies. Object relational mapping will almost double your query time. So you can use a in-memory database, but an in-memory database will never give you objects, so you have to use this object relational mapping behind the scenes. On the server, we saw that this is really slow, and to accelerate database queries, we just add a cache. And we can see the complexity of our system will increase. Now we have a cache. Is a cache really fast? It should be fast. But when we measure the access time to just read data from a cache, then it's interesting. So mostly not milliseconds and mostly not microseconds. Mostly we have access time in milliseconds. It's because of the object has to be serialized into the memory and have to be deserialized when reading from data from the cache. And on the server, it's server side, it's more dramatic because we talked about a single node application. What about distributed applications? So with distributed application, we have more challenges. So if we change data on one of these nodes and store the data in a database, then everything is fine because the application node and the database are in sync. But all the other nodes are not in sync with the database. So we have a problem here as well. So on the server side, so we can solve this problem by adding a cache or putting the cache between the application nodes and the database. And in a cloud, we have to avoid single point of failures. So we use a cache cluster here as well. So we have a third layer. It's our caching layer. It's a distributed cache. And in terms of load on the database, high availability, and so on, we need replication of our database as well. So we have a third cluster. And this is a common enterprise application architecture on the server. That's crazy. So a lot of machines, 3 clusters to maintain, to set up, and to test. And this is why we have expensive latencies, high complexity, and of course, our costs will skyrocket in the cloud. There are some great facts about our Java virtual machine and also on Android, of course. So because Java has a JIT compiler, so the JVM is very fast. It's not as fast as a C program, but it's really fast through runtime because of the just-in-time compiler. We have a great data structure in Java or Kotlin. We have objects, we have object graphs. So we can store simple lists with sensor data or high complex object graph with circular references and millions of billions of nodes in memory. So we have a multi-model data structure from the beginning. And we have a great query language. We can search and filter in memory with Java Streams API. When we search a really complex object graph in memory with Java Streams API, it mostly takes only microseconds. When we talk about the query time of a database, we talk about milliseconds. Microseconds versus milliseconds. So it's 1,000x faster when we use Java Streams API for searching and filtering in memory. 1,000x faster than a comparable SQL query. That's awesome. So, what about costs? Great thing, great news here. The cloud vendors provide object storages. In comparison to a relational database, let's assume we need 250 gigabyte database. We choose AWS, PostgreSQL, for instance. It costs around $8,000 on a suited machine annually. If we need high availability, if we need replication of our database nodes, our price will double or triple. If we need some more nodes, 6 nodes, 7 nodes, so we will pay around $50,000 per year. With a cloud object store like AWS S3 or Google Cloud Blob Store, Oracle Cloud Blob Store, Azure Cloud Object Store, we pay for 250 gigabyte only around $70 per year. That's it. Super cheap. And they care for uptime. They care for data center replication and for backups. So everything is included. Super cheap, 99% cheaper than a comparable database service in the cloud. The only thing missing is persistence. We are not able to store data with a programming language. That's crazy, actually. But there is a functional principle called system prevalence. So it's an architectural pattern, and it's very simple. It says, keep your data in memory, process data with your programming language, because it's more powerful, you have better performance, it's a simple architecture, and just create snapshots of the system state. And with Eclipse Store, you can do this now. And not just creating a snapshot and storing the entire database or loading the entire database back into memory. No, just creating micro snapshots from the changes. So if an object changes, only the delta is stored persistently on disk. You can now use it for free. It's open source, and it's an Eclipse project. The first release is now released. The project was started 10 years ago on the server. It also now runs on Android. So what actually is Eclipse Store? It's a persistence framework similar to Room, but not for relational database anymore. There is no database at all. So you just serialize your objects persistently in a file on the device or in the cloud. And it allows you just to store the changes. It creates a binary and stores it persistently wherever you want to store it. Vice versa, when you start the app, then the engine loads the object graph into the memory, but only the object IDs. No data are loaded initially. So you can define which data should be loaded initially into the memory. You have lazy loading, so this is very easy to keep only the hot data in the memory. So you can store just the diffs, and you can load just subgraphs in the memory when data are needed. So and it runs on Android as well. It's included in many server-side microservice frameworks. So it's a part of Oracle's Helidon, Project Helidon. It's part of Micronaut, and we have also integrations with other microservice frameworks. And of course, as I mentioned, it runs on Android. How does it work? So what we did when we have a look inside a database, in a database server, so this is very important. In a database server, we have, of course, we have computing power, we have a machine, we have storage, we have a database management system, and a lot of memory. So we need a lot of memory. And in our application architecture, we replace object relational mapping like Room or Hibernate on a server with Eclipse Store. So we keep data in memory, we search in memory, we don't need a local cache anymore, so we can skip the local cache. Because everything is already in memory, we process data with Kotlin or Java, we don't need a database management system, everything is covered by the business logic of our app, so we can skip the machine on a server, a database server machine, we can skip database management system. The only thing we need to persist objects now is storage, plain storage. And it can be plain files, it can be an object store, or even a traditional database, because a traditional database like SQLite or MySQL can store binaries. So there are performance tests. It's proven it's extremely fast. Because of the power of the Android runtime or the JVM on the server. On a mobile device is also the same functional principle. It serializes your data, your objects directly on the device. You can store the entire state or only parts of it and keep the hot data in memory. As I mentioned, you can store your objects also seamlessly in a cloud, in persistent volumes running on Kubernetes, in NoSQL databases, but it's recommended to store it in a cloud in blob stores because they are fully managed by the cloud providers. For all developers developing also backend services, it can also be used in a cluster on the server. So we have replication, so you can replicate and distribute your object graph through 100 or even 1,000 JVMs seamlessly. And then you can replace all of this complexity with Eclipse Store, and this is how it works. So we replace the application node. We don't need local cache, no object relational mapping anymore, just Eclipse Store nodes. We keep the data in memory. They are synced through multiple JVMs, which means it works also like in-memory database and a distributed cache, so we don't need a distributed cache anymore. We store data in a blob store, which means we don't need a database cluster anymore. So we remove the database cluster, just use AWS S3 or other blob store. We don't need a cache anymore. And so this is your new architecture on the server. So plain architecture, core Kotlin or Java, no more databases, no more database costs. You save 99% costs in the cloud. And this Eclipse Store cluster also can be queried by mobile apps, by serverless functions. So you can query this cluster with lambdas, for instance. And the microservices can be written in any programming language by just calling the cluster by using REST. Here are the connectors to all important data storages. As I mentioned, it runs wherever a JVM is available. The only requirement is Java version 8. And you can use it with, of course, all JVM languages, runs on Android and on GraalVM GraalVM native images as well. As I mentioned, Eclipse is well known for the IDE, but Eclipse also runs more than 100 open source projects. Eclipse Store is now a new Eclipse project, and it becomes a standard, similar to the JPA standard for object relational mapping. And on the top of that, as I mentioned, we provide a cluster for highly scalable applications in the cloud. The benefit is you can design your object model freely. Just need POJOs. To use it, so you can download it as a Java library via Maven, include it very easily in your project, and then you can design your object model completely freely. You forget everything you have heard about a database. It's just Kotlin or Java stuff. So you can use circular references, inheritance when you need it. All Java or Kotlin types are supported, collections, whatever, and it can be stored. As I mentioned, there are no annotations. There is no superclass you have to use. There is no interface to implement. Just plain classes, plain POJOs. For storing objects persistently on disk, it's just a store method. Just call a store method, and the changes are serialized in a binary format and stored persistently on disk. For fetching data from the storage, you can use lazy loading. It's just to use a wrapper class that's very easy to use. And for searching and querying, filtering, you can use Java Streams API. That's executed in memory. It's type safe. No more classic selects are needed. So there are some rules, or The only thing is, it's a paradigm shift in database programming, of course, because there is no more database. So with a database paradigm, we have a database server, it's a machine and storage, and we have an application tier that runs on a different machine. And with Eclipse Store, we have now a new paradigm. All data are kept in memory. We search in memory. We use the programming language. So there is no more database server. It's just storage. So keep this in mind. Use cases, of course, you can use it for low latency applications if you need high performance for these new applications, new kind of applications, microservices, serverless functions, mobile and edge applications, for caching, AI, machine learning. So these are common use cases, but it's just for storing data, so you can use it wherever you have to store data, of course. There are also some challenges, and it's because all solutions have challenges. It's built for Java and Kotlin developers only, so, and it's a paradigm shift in database programming. There is no SQL support, so this might be bad for some people. It's great for Java developers, Kotlin developers, and it's not suited, of course, for DBAs, so mostly DBAs don't like it. So, and it's because many people have visited us at our booth and we get great feedback. Thank you for that. And this is why I want to give something back. We have a gift for you guys, and it's, this is an online training. So if you, we provide an online training, especially for DroidCon participants, 3 hours online training for free, Eclipse Store on Android, getting started, and on a server for getting started, you can enroll for free if you like, and check this out. So as I mentioned, the project is completely open source. It's an Eclipse project, it's under the EPL license. You can use it for commercial purpose. You can use it for developing proprietary software. And of course, it's open source. That means you're invited to contribute and support the project. Give us feedback. So we are looking forward to get your feedback to improve the software. It is not experimental or a new project. It is in production use for many years. So companies like Allianz or Fraport are using it. So if you have ever been to Airport Frankfurt and your luggage was scanned, then this scanner app runs with Eclipse Store and syncs data with the server. And the server also runs Eclipse Store. And here we save a lot of machine, a lot of cloud costs, so tons of cloud costs, and was much simpler to implement than any database solution. All right, so if you have any questions, please feel free. No more time for questions? Okay, thank you very much for joining, and have a great day at DroidCon. Thank you.